Okay, well let's graph our first couple of parabolas. Here we have the equation of a parabola, and that's written in that nice standard form where it's easy to find the vertex. But first of all, let's write out what A, H, and K are. A is the coefficient in front of these parentheses, so it's just a 1. And then H is going to be a 2 because we have x minus h, so h is just a 2. You don't take the negative sign because we need x minus h and we want h. If it were x plus 2, then h would be a negative 2. And on this one, you take exactly the sign, everything, plus 1. So k is a 1. Well, a is positive, right? Opens upward. Since a is greater than 0, I'll remind us a is equal to 1. The vertex is the point hk, which for us is h is a 2, k is a 1. 2 comma 1. Let me go ahead and graph that over here, plot it. 2, 1. That's the vertex. And it opens upward, so we almost know what this graph looks like. Now, what are the x-intercepts of this graph, of this parabola? X-intercepts. Well, clearly there is no x-intercept because this is the vertex and it opens upward, right? So it's not coming downward where it crosses the x-axis. So the x-intercept's none. The y-intercept is easy. It's f of 0. Let's figure out what that is. F of 0 is 0 minus 2 in parentheses squared plus 1. So that's a negative 2 squared, which is 4. 4 plus 1 is 5. So 0, 5 is the y-intercept. 1, 2, 3, 4, 5. All right, and we'll graph it in a second. Let's plot a couple of other points. But watch how easy this is to get at least a fairly close picture of the graph. Where is the axis of symmetry? Or what is the axis of symmetry? It's the vertical line x equals, let's go to the vertex and get the x value. X equals 2. We'd already plotted it, so we know what it's going to look like. This is the axis of symmetry. It's not part of the graph, so I drew it really lightly. But the beauty about graphing parabolas is it's a mirror image on the left and right of this axis of symmetry. So, if I've got this point, I know I can go to the right from the axis of symmetry. Notice if I go to the axis of symmetry and go left 2, I get that point. And now if I go right 2, I get another point. And if we plugged in, we would find out that if we plug in a 3, we're going to get a value of 2. I think that's right. If we plug in a 3, we would get 3 minus 2. We'd get a 1 squared plus 1. Yep. And then also if we plugged in a 1, we'd get the same value. So the parabola looks something like that. And there's something important that I want to discuss about this shape. This shape, the shape of this graph is exactly the same as the graph of g of x equals x squared. It's just shifted. It's shifted to the right 2 and up 1. But the shape is exactly the same. And the reason it's exactly the same is because a is a 1. If a were a 2, it would be stretched up taller, twice as tall. If a were a 3, it'd be 3 times as tall. And if a were a negative 1, for example, it would simply be the upside down. It would be a graph that is upside down, rotated, but it would be exactly this same shape. It's this coefficient. If it's a 1, if it's different from 1, then it either stretches it taller or shrinks it shorter. And that will help you if you remember that. It'll help you in graphing parabolas. Let's look at the next example. All right, so this one says f of x is negative 2 times x plus 1 squared minus 4. So a is negative 2. H is what? Not a 1, you have to take the opposite of 1, negative 1. K is negative 4. You do not change the sign on this. Negative 4 is K. All right, so that's negative. So it opens downward. Since A is less than 0. A is negative 2. The vertex is HK, which would be for us negative 1, comma, negative 4. Let me go ahead and plot that right now. Negative 1, 2, 3, 4. That's our vertex. Oh, goodness, this is, we're not going to use much of this graph, are we? We're just going to have to be really rough on this. It's going to open downward. Okay, so what are the x and y intercepts? Well, is there an x-intercept? Notice it's opening downward. So no, there is no x-intercept. But there is a y-intercept. It would simply be f of 0, which would be negative 2 times 0 plus 1 squared minus 4. So that would be 1 squared is 1, negative 2, minus 4 is negative 6. 1, 2, 3, 4, 5, 6. All right, and we know what the axis of symmetry looks like. It's the vertical line that goes through the vertex. So again, the beauty of graphing these is we know if this is a point, we get another one for free. Go to the left from the axis of symmetry. Instead of going to the right one, go to the left one. And I think that's all I'm going to do for now. I'll probably go all the way off the paper. But notice this is not going to be exactly the same shape as the other one. It's taller and thinner. This one you can see was wider. This one is thinner by a factor of 2 because of that guy right there. And negative 2 means it's going upside down and it's opening downward. Now, before we finish this, I forgot to do this on the previous one, but let's do this one first and then we'll go back to the previous example. We graphed it, but what are this and this? Domain of the function f and the range of the function f. Well, do you remember we're talking about functions, and this is a polynomial. It has no square root in it, so you can't get a square root of a negative. It has no fraction in it, so you can't get a division by 0. So the domain is all real numbers. And that's true for every single parabola in existence and, in fact, for all polynomials. The domain will always be all reals. There's no number for x that I cannot plug in. I can plug in any real number into this function. Now the range, that's going to be a little bit different for for the two parabolas we graphed. What's the range? The range is the y values. It's the height of the function. So what I want you to tell me is, what is the lowest possible value on this graph? And what is the highest possible value on this graph? Well, the lowest, it goes down forever. So it goes down, it starts at negative infinity, and then the highest point that it gets to actually is the vertex, right? And that y value is a negative 4. So this is the range, and you must put a square bracket on it because negative 4 is actually in the set. This graph has a height of negative 4 right here. When x is negative 1, the height of the function is negative 4. Okay, to finish up, let's go back to the last problem and do the domain and range. Well, domain is easy. You don't even have to look at it. You know it's all real numbers. So the domain of f is all real numbers. If you prefer to write that as an interval, you could say negative infinity, comma, infinity in parentheses. And then the range of f, well, let's see, this one, what's the lowest height that function takes on, the lowest value of this function that we've graphed? It's right here at the vertex. And what's the height? 1. And how high does it go? Well, the arrows go up. It takes it up to a height, goes all the way to infinity. And in the, I think the next video, I'm going to ask you questions like, does this parabola have a lowest point or a highest point? Well, it doesn't have a highest point because it goes up to infinity. It has a lowest point. And where does the lowest point occur? That's the x value I want. What x value tells you where the lowest point occurs? 2. And what is that lowest point value? 1. 2, 1 is exactly the vertex. And the reason it has this minimum is because it opens upward. When it opens downward, like in this example, it doesn't have a minimum, because this goes all the way down toward negative infinity, but it does have a highest, a maximum value, and it occurs at x equals -1. So at x equals -1, we get the biggest value of the function, which is -4. At -1, the biggest value is -4. And it's a biggest value, again, because it opens downward.